Circular measure includes calculation of length of arc, area of a sector within a circle, area of segment, and even the angle subtended in a sector. So let's look into some fundamentals needed for this chapter. First, let's start with angles. I'm sure you know that pi radian equals to 180 degrees. Therefore, 1 radian equals to 180 over pi, while 1 degree equals to pi over 180. In a circle, the ratio of length of arc to the circumference of the circle is equivalent to the ratio of the angle subtended by the sector to the total internal angle of the circle. Simplifying the ratio, we get S equal r theta, which is a formula to find the length of arc of a sector. By using the same method and the ratio of area of a sector to the area of the entire circle, we are able to derive the formula of area of a sector. These two are the fundamental formulas in circular measure. This diagram shows a sector of MJKL of a circle, centered M, and two sectors, PJM and QML, of the two other circles with centers at P and Q respectively. Now, given that the reflex angle JML is 3.6 radian, we have to find A, the radius of the sector MJKL, B, the perimeter of the shaded region, C, the area of the sector PJM, and finally D, the area of the shaded region. First, isolate the triangle MQL. We need to find the length of ML, which is the radius of sector MJKL. MQL is an isosceles triangle, so by adding a straight line AQ, we can create a right angle triangle QAL. We know that the value of angle AQL by halving 1 radian, getting 0.5 radian. Using sine equals opposite over hypotenuse, sine 0.5 radian equals AL over 5. Therefore, AL is 2.397. ML equals 2AL, which is equivalent to 4.794 centimeter, which is the radius of sector MJKL. For part B, we need to calculate the length of arcs of JKL, JM, and ML. Arc JM is an easy one. Using S equals to r theta, JM equals 5 times 1, which is 5 cm. Arc JKL equals r theta, which equals 4.794 times 3.6 radian, and it gives you 17.26 cm. Therefore, the perimeter of the shaded region is 5 plus 5 plus 17.26, and a total of 27.26 cm. And for the next part, the area of sector PJM. Using A equals half r squared theta, we get half times 5 squared times 1, which is 12.5 cm squared. The area of shaded region is made up of the area of sector MJKL minus the two little segments of JM and ML. The area for sector MJKL is half times 4.794 squared times 3.6, which gives us 41.37 centimeters squared. Now, the tricky bit is calculating the area of segment JM and ML, so we can minus that from MJKL's total area. So segment JM equals half times 5 squared times 1 minus half times 5 squared times sine 1 radian, giving us 12.5 minus 10.52, which is 1.98. There are two segments, so the shaded region equals 41.37 minus 2 times of 1.98, giving us 37.41 cm squared. I'm Noel, Chia, and I'll see you in the next episode of SPM Top Tutor Additional Mathematics.